Welcome back to the Chem OG. Today is Strategy Monday, and what we're going to be talking about strategically today is electrochemistry. Galvanic cells have a cell potential that is positive. Electrolytic cells have a cell potential that is negative. Now, galvanic cells are spontaneous, they happen on their own. Electrolytic cells need the use of some electromotive force like a battery. And so the question that we're posing today in terms of strategy is how can we quickly determine the sign of the cell potential by looking at a redox reaction? So how can we figure out, is it a galvanic cell or is it an electrolytic cell? And the way we're going to do that is by following a few steps. And so the first thing I want to introduce is, here's a reduction table. And if you notice in a reduction table, all of the reactions have electrons on the left-hand side. And that is because anytime you have a reduction, you have a gain of electrons. You're picking up electrons. And so all of these reactions are going to be reduction reactions that we see in a reduction table. And we're going to use that to our advantage. Because every time you have a chemistry exam and you're looking at these reference values, every single time what you're looking at is a reduction reaction. So here are the steps we're going to follow. Step 1. We want to identify the species that is actually getting reduced, and we'll use the reduction table in order to do that. And then after we've identified the species that is getting reduced, the next thing we're going to do is we're going to see if it indeed has a higher reduction potential in the table. If the reduced species has a higher reduction potential, it means that the cell is galvanic. And so when I'm talking about finding a higher reduction potential, it just simply means look at the entry in the table and see its value. Look at the entry in the table for the other thing that's participating in reaction, then look at its value and just compare the two numbers. Now, when you're comparing two numbers that happen to be negative, make sure that you're picking the less negative one. So whenever you're comparing two negative values, the larger one is the one that's less negative. So if we're saying the reduced species is a higher reduction potential, that means if we're comparing two numbers that are negative, we're looking for the less negative one. So we're going to take a look at two example reactions and apply these principles. So the first reaction we're going to take a look at is this one. Okay, now don't worry, we've balanced things out in terms of electrons and all that good stuff. But what I want to do is I want to compare these species in the reduction table that we had. So if we take a look at the two species that are reacting with each other, I have permanganate and I have a little bit of nitrous oxide. And in the end, I'm going to get manganese and I'm going to get nitrate. And so I'm going to try to find the reactions pertinent to those species in my reduction table. So permanganate's reaction is right here. And the reaction for nitrate is right here. Now what I notice is the permanganate is on the left in this reaction and it's also in the left in my overall reaction. That means that, well, this is the reaction that's in a reduction table, so that means that the permanganate is the one that's going through a reduction. You'll notice that the NO over here is not on the reactant side, it's on the product side instead. So that means this reaction must have been flipped in order to go into this overall reaction. Another way of looking at it is the nitrate here is the one that's getting reduced, but because the nitrate is on the wrong side of the reaction arrow, it means again that we must have flipped this reaction. So between these two values, the higher one is 1.5. And that belongs to the permanganate, whose reaction we didn't have to change. So the permanganate is reduced and has a higher reduction potential. So that means that overall this reaction is going to be spontaneous. Okay, so again, what we did was we've identified that the permanganate is on the correct side of the reaction arrow. It's the one with the higher value, spontaneous reaction. Now let's do another example, and we're going to do it a little bit more quickly. So let's take a look at this reaction. And let's find those values in a reduction table. So the one for chlorine and the one for oxygen are these two right here. So the oxygen is on the left side, and it's also on the left side in this reaction. So that means that O2 is the one that's getting reduced. In terms of the two values, the value for O2 is actually the smaller one, not the larger one. So the oxygen is getting reduced and has a lower reduction potential. And if it has a lower reduction potential, that means that the reaction that I'm looking at is going to be non-spontaneous, or an electrolytic cell instead. And so that means that the opposite reaction would be the one that is spontaneous. So this is a really quick way of using the reduction table, spot checking where it is that your different species are. And if it is the case that your species that's getting reduced has a higher reduction potential, you're looking at a galvanic cell. If it's got a lower reduction potential, then you're looking at an electrolytic cell instead, and we're going to need to provide some sort of outside voltage source. Happy Strategy Monday! Hope you enjoyed today's lesson. Please be sure to subscribe and like. And if you have any questions or any suggestions for upcoming sessions, please put those in the comments section.